David goes into a candy store with $5. He buys 9 peppermints for 15 cents each, and some sour candies. Each sour candy costs 25 cents. Enter the maximum number of sour candies David can buy. So this is what we're being asked to find. What is that maximum number of sour candies he can buy? If he's got $5 and he already spent money on these peppermints here, they cost 15 cents each. So we don't know how many sour candies he can buy. Whenever we don't know something, it's going to be our variable. C will be the number of sour candies. That's going to be the variable in our word problem here. Now, they tell us he buys 9 peppermints, and they actually tell us how much each of those costs. So it's going to be 9 times 0.15. And he also buys some unknown number of sour candies, C, and those cost 25 cents each. Now this represents the total he's going to spend, the peppermints plus the sour candies, and he cannot go over that $5 that he walked in with. So I knew this was going to be an inequality based on what the problem told me here by this term maximum number, right? Whenever they're asking for the maximum or minimum, it's going to be an inequality type problem. And I knew the inequality had to open in this direction because the mouth eats the bigger side. And this side cannot be more than $5 because that's all he's got. Let's set about simplifying this. So we have 9 times 0.15. We can just multiply that out. Let's figure out what that is. Now, whenever you're multiplying, it's always best practice to put the number with more digits, so with the longer number, as in this case 0.15, on top. 9 times 5 is 45. 9 times 1 is 9, plus 4 is 3. Then we'll count the decimal places. 1, 2, 1, 2. So it's 1.35. Okay, so in total, he spent $1.35 on those 9 peppermints. All right, we're moving right along. Just rewriting this problem now that I've updated that. Okay, and I'm looking at this to see what can I simplify next. Well, I can certainly subtract this 1.35 from both sides. Getting rid of that constant that's on the same side as the variable. 1.35 minus 1.35, that's gone. And let's subtract this. 0 minus 5, we're going to need to borrow. I can't borrow from there. Let's come all the way over here. It's going to become 4. That would become a 10. We borrow from that. That's now a 9. And then finally we get to 10 right here. 10 minus 5 is 5. 9 minus 3 is 6. And 4 minus 1 is 3. And we're very close to solving this problem now. We have C times 0.25 is less than or equal to 3.65. We just need to get C by itself. So let's do the inverse operation of what's being done to it. And we're going to divide by 0.25. Divide by 0.25. And we're going to do some long division to solve this. Top number goes inside the house. We go 3.65 divided by 0.25. Okay, so when you're dividing by a decimal on the outside and you have that decimal here, we need to move that over. 1, 2. 1, 2. So now the decimal is right here after this 5. So now let's set about solving this. 25 goes into 36 one time. 1 times 25 is 25. 6 minus 5 is 1. 3 minus 2 is 1. Bring down this 5. 25 goes into 115. Well, I can count by 25s. 25, 50, 75, 100. 125 would be too much. So 25 goes into 115 4 times. 4 times 25 is 100. And then I can bring down a 0. 25 goes into 150. That'll be exactly 7 times. 7 times 25 be 150. So it's 14.7. Now, we need to read what this question is asking us carefully. It says, enter the maximum number of sour candies David can buy. So the most he can buy. You can't buy 0.7 of a candy, okay? You can either buy 14 candies or you can buy 15 candies. The most he could even purchase with his earning power is 14.7, but that's not possible to buy that amount at a store. So our answer is going to be 14 candies. The maximum number of sour candies we can buy is 14. It's very important to go back to the question and see what they're asking and kind of use that common sense check, remembering that if you're at a store, you're not going to be able to buy 14.7 candies, right? Now, if it was 14.7 pounds of something, you could do that. But 14.7 candies, they're not going to sell you 0.7 of a candy. So 14 is the most he can afford.